I'm going to continue where I left off. Types of rock. Crustal rocks and minerals appear in a bewildering array of types, since chemical elements can combine in myriad ways. But in broad terms, geologists recognize three kinds of rock. Rocks that form in a molten state are called igneous. These include basalt, which erupts as molten lava, and granite, which forms deep within the earth and is exposed by erosion or geological activity. Sedimentary rocks are formed by the slow accumulation of layers of particles such as sand, mud, or organic debris. Shale, sandstone, or limestone are common sedimentary rocks. Metamorphic rocks are those that have been altered by heat, pressure, or both. Metamorphism makes a rock harder and denser, but traces of the rock's original nature are usually preserved. The process can turn shale into slate, sandstone into quartzite, and limestone into marble, and so on. Earth is a geologically active planet, and these three types of rock are involved in a continual process of recycling, driven by weathering, heat, and pressure. Although Earth formed about 4.6 billion years ago, the oldest known rocks are about 3.9 billion years old. And these are rare exceptions. Most of the surface is only about 100 million years old. This explains why we do not find the number of craters here that we do on the Moon or Mars. While Earth experienced just as many impacts, most craters have been eroded by the weather or erased by geological activity. So in these pictures, it says sedimentary rocks, such as sandstone below left and right, often form in distinct layers and may be eroded into dramatic shapes. Land, it says, covers only 30% of the Earth's surface. The collision of tectonic plates created landforms such as the Himalayas, seen here from space on the left. Continents adrift. Earth differs from other planets in that its crust is made up of slabs of thin rock called plates. Driven by currents in the upper mantle, the plates, which number more than a dozen, carry the continents on their backs like rafts. Meteorologist Alfred Wegener argued for continental drift, as he called it, in the early 1900s. However, the idea was not generally accepted until the 1960s, when geologists found that new oceanic crust was constantly being formed in mid-ocean ridges on the seabed. The theory of how new crust moves away from the mid-ocean ridges and disappears at the edges of continents is called plate tectonics, and it has revolutionized geology. As the edges of the crustal plates collide, they rift, overlap, and fold, recycling their rocks and remaking the surface of the planet. The Himalayan mountains, for example, mark where the Indian plate is being forced under the edge of the Asian plate. The Rift Valley of East Africa, on the other hand, marks where the continental is rifting apart to eventually form a new ocean. A watery planet. Conditions on Earth's surface depend on the interaction of two spheres, the atmosphere and the hydrosphere. The hydrosphere is the water on or near the surface. This water is found in oceans, rivers, and lakes. It is found below the surface as groundwater. It is locked up in frozen polar caps and glaciers. It exists as vapor carried in the atmosphere. Earth is the only planet where temperatures allow the surface water to exist in solid, liquid, and gaseous states. Oceans make up 97% of the hydrosphere and contain enough water to cover the planet 2 miles deep. The only reason we are not underwater is that the continental crust some 30% of Earth's surface, has an average elevation high enough to keep it above sea level. The sea appears so eternal that few people think about how it began. Its origin is, in fact, a scientific puzzle. Some water must have formed with the planet and then erupted from volcanoes, but Earth's birthplace in the solar nebula was too hot to allow much water to exist. Comets, however, are loaded with ice and organic elements, and many scientists think that most of the hydrosphere was deposited by catastrophic comet impacts early in Earth's history. Much smaller impacts occur to this day, continually adding water to the hydrosphere. Cool.